looking at, Boston, for example, at the very top there goes from a snow load of 40 PSF to 74 PSF. I guess, what does that mean in reality? Are we, in Boston, all of a sudden a 2x factor, nearly a 2x factor of snow load over the last 6 years? Or I guess, how does that actually get applied when you're doing this analysis?
Yeah, so it's not as scary as it looks, but definitely there's been some um, shift in how the snow loads, the ground snow loads have been determined historically. It seems like they've been able to get more, I guess, site-specific data, and over the last few years, their database has become more complete. So, some changes have been applied in that regard. But the main change or difference here is that in ASCE 716 and all the versions before that, snow loads were considered nominal level loads. In ASCE 722, they switched them to ultimate level loads. So they basically raised it to the same level as wind and seismic, meaning that there's now, if you want to really do an apples to apples comparison, you have to convert the values on the right-hand side into the nominal equivalent by factoring them. The factor that they have currently for ASCE 722 applied to snow loads is 0.7. So if you really want to see what happened in Boston, you got to multiply this 74 PSF by 0.7, which I think it equates to 51.8, 52 pounds per square foot. And you can see that there's a bump from 40 to 52, but not as bad. And yeah, we're seeing that in many places that the snow loads are just going to have to get adjusted.
I guess the question that I have is, how do you properly apply it then? So if you are installing you have a PV system you're going to install on this roof now, we just did that math, the 40 PSF, really more of the apples to apples, as you were saying, is that more of a 52 pound. So we're saying that's what the loading up for the snow load is now. And so now adding solar onto that, we may have a situation where structurally the building may not even pass the updated snow load. Am I understanding that, or am I thinking that properly?
Yes, absolutely. And that increased snow load has two implications. One is on the racking side, it's potentially going to lead to smaller spans in the snow regions, and Matt and Ryan can speak to that. But on the structure side, where you're doing a structural evaluation to see if the roof can withstand the added loads due to PV, they make you check for all these different combinations of loads. And so if the snow load increased and the original structure wasn't designed for that magnitude of snow, then there's a chance that you're going to end up with rafter upgrades. And that happened in some states like Massachusetts and Connecticut in the past iterations of the code. Then they increased the loads. And so this is going to exacerbate that even more.